Hey guys, welcome. This is our 1.5 video exploring angle pairs. So we're going to try and identify special angle pairs and use their relationships to find angle measures. So let's go ahead and get started. Alright, so make sure you write this whole box out because these are our angle pairs. Alright, like I said, geometry, we use our vocabulary, our postulates and theorems to help us identify pictures and create equations. So let's go ahead and get started. I'll talk about them. You can pause the video and write these down. Number one, adjacent angles. That means they are next to each other. They share a common vertex, okay? But they have no common interior point. So one's next to two, but they're not a part of each other. Vertical angles are two angles whose sides are opposite rays. So they're opposite of each other. Whoop, whoop. Okay, so they're directly opposite of one another. Complementary angles. Okay, complementary angles are two angles that their sum is 90. So 47 plus 43 is 90. They're complementary, so they don't have to be right next to each other. They could be separate. They just have to add up to 90. Supplementary is the same thing, except for they add up to 180. Okay? All right, moving along. Pause. Next, we have a linear pair. Okay, so if you look at this right here, ABC, we call angle ABC a straight angle, which is 180 degrees, but we can also call these two angles together a linear pair. It's a pair of adjacent angles whose non-common sides are opposite rays, which forms a straight angle. So I want you to go ahead and write this down with this picture. And then also include this postulate. If two angles form a linear pair, then they are supplementary. So a lot of times you'll hear linear pair, supplementary. They're very similar. The difference is linear pair has to be adjacent to each other versus supplementary, they just have to add up to 180, but they could be separate from one another. Okay? Okay? Okay, moving on. All right, our last piece here is an angle bisector. Okay, so we want to go ahead and draw this picture. And it says an angle bisector is a ray that divides an angle into two congruent angles. That's all you have to write there. That's fine. So this ray, AY, cuts our larger angle into two congruent angles. We call that an angle bisector. Okay? Let's look at some examples. Okay, so this is our first example. We'll call it example 1. And it says, use the diagram shown is the statement true. BFD and CFD are adjacent angles. I'm going to use colors here, and I highly recommend you do as well. BFD, so we start at B, go to F, and then go to D. I'm going to switch colors here to red. It's like Christmas colors. Christmas time, Christmas time. Okay, and CFD. All right? So are those two angles adjacent? Well, they look really close to each other. Adjacent, a lot of times we mean right next to each other. But a part of our definition said they can't have the same point inside both angles. You notice if I put a point right here, it's inside of both angles. So these are not adjacent angles. So is this statement true? It is actually false. Okay, let's look at our next part. Okay, so this is part B, still part of question number 1. And it says, is AFB and EFD vertical angles? So AFB, let's go ahead and find that. AFB is right here. And then we have, go back to green, EFD. EFD is right here. Now they are opposite of one another, but are they opposite rays? Okay, so this is kind of hard to see because I drew over this, so I'm actually going to go ahead and erase this so it's a little bit clearer to see, but I'll use a highlighter, maybe that'll be a little bit easier to see. This angle here, okay, versus this, let's go, gotta get that oh so carefully right there. This angle there. Okay, they're not quite opposite rays. If we look carefully, we have EC going through and AD going through. This BF is throwing it off. So are these vertical angles? No, they are not. They're very close, but they are not. So this is, again, false. Okay? So we want you to write this again, but the picture we had before was fine. All right, moving forward. All right, and this is the last part of this same question. AFE, okay, so AFE, AFE, so 62. So we have 62. And then we're going to do BCF, BCF right here, which is 28. We got to add them together. Does it make complementary angles? Now, complementary angles, again, are 90 degrees. Supplementary would be 180. If we add these together, we actually get 90 degrees. Is it okay they're not adjacent? That's fine. That is correct. So this is a true statement. Okay? Let's move on. Okay, number 2. Write this down. What can we conclude from the information in the diagram? All right, well, let's just go ahead and go through a couple things. First of all, we're just going to bullet point these. The first thing that shoots out to me is angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2. Next, what do I see? See 5 and 4? Angle 5 and let's do and angle 4 are linear pair. Okay, linear pair. Okay, and because they're linear pair, they add up to 180. So they'll equal 180 if you add them up together. Okay. Okay, what else do we have here? We also have 5 and 3 are vertical angles. So if you take a look, 5 and 3, they're formed by two pairs of opposite rays, and that's a 3 if you believe it or not. So these are vertical angles. Vertical angles. All I want for Christmas is vertical angles. I don't know why I'm on this Christmas kick. Maybe because like the red and green I was doing earlier, or something like that. Okay, there's a lot more we could talk about. We could talk about some more adjacent angles and supplementary angles, which 5 and 4 would also be supplementary because they add up to 180. So a lot of different things. But let's go ahead and move on. Okay, this is our third example here, and it says KPL and JPL are a linear pair. So that's why we have this picture drawn. I already got it drawn in for us. But you would have to do this without a picture to start, so we want to be able to draw the picture. So linear pair shows the straight angle. We don't know exactly where this goes, so it doesn't matter kind of how I put it. And it says KPL. KPL is 2x plus 24, so we write it in. Again, drawing the picture, hugely important. And then we have JPL. Over here is 4x plus 36. What's the measure? So this is very similar to our angle addition postulate. We know that a linear pair adds up to 180, so we're going to get 2x plus 24 plus 4x plus 36 equals 180. And again, have your calculator ready. You always want to be ready to use your calculator. We don't want to make a mistake here. So we got 6x. We're going to add these together, 24, 36. I know it off the top of my head, but we're going to go ahead and double check that it's 60. It is 60, so we're good. Equals 180. You should subtract the 60 from both sides. We get 120. Whoops, that got all messy. That was really weird. And then divide by 6, and x should equal, there's like a little thing on my screen. It's not on your screen, it's on my screen. Sorry. And divide that by 6. Well, how many 6 goes into 12? Twice, so it should be 20. What's the measure of KPL and JPL? We got to plug them back in. So I'm going to just plug in 20 here instead of x, and 20 here. Come on, there you go. Instead of x. And so what are we going to get? KPL is going to be 2 times 20 plus 24. So we get 64. And we can put degrees on there. And then we're going to get 4 times 20 plus 36. That equals 116. Again, we should check to make sure if we add them together we get 180. And it turns out we would. Alright. Okay, so here's our last one. AC bisects angle DAB. So let's go ahead and draw a picture real quick. DAB. AC bisects it. So the word bisect means it's going to cut it into 2 equal parts. DAC is 58. So it's trying to ask me, what is the whole angle DAB? Well, if this is 58, this is also going to be 58. So we add them together, we get 116. Okay? That's it. That is all for me for the video today. And we are done.